Okay, guys, I think we are live now. Just let me know through chat if you can see me and hear me. Good evening to all those who have joined. I hope to make sure that your PNC is perfect by the end of this session. I know that this is one of those topics not a lot of people put in a lot of time in, but I want to make sure that in this one session, everything is revised, you are clear with all your concepts, you know exactly what to do, and you will be able to solve the most expected questions from this particular section. So good to see all those who have joined. Hi Ainoshi. And all those who have joined, just put in the chat, just let me know how your preparation is going. If you're nervous, anxious, how everything is going. I'd love to know how your preparation is going. And another request for those who have joined, please like this stream. It helps us quite a bit. It motivates us to do more of these streams. So please join, please like the stream. So good to see a lot of people are joining in. I'll wait a few minutes because we have started early. And in general, I would want this session to be as interactive as possible. So before we start, just let me know how things are going because we have started a few minutes early and people are yet to join. So just let me know how your preparation is going, what is working, what is not working. And in this stream, I want to answer as many questions as possible. We have quite a few formulas to cover, quite a few questions to cover, but I also want it to be interactive. So let me know how your preparation is going. Hi Sparsh, good evening to you too. Hi Mohan, highly motivated, very good to hear. Keep the motivation up. It's just the last few days, you have to keep at it. Keep working with every single fiber of your body, every single last energy that you have, just directed towards this. There will be nothing stopping you from cracking CAT then. So very, very good. Hi Aniket, hi Benton. How to improve mock score in CAT, dash CAT. So I will say that basically when you're analyzing the mock, between each mock you have to identify small areas of improvement. If you say that suddenly from mock 1 to mock 2 I'm going to try to improve by 20 marks, it will be difficult to do. But you should put small goals. You should say that between mock 1 to mock 2, in quant I want to do one more question right or two more questions right. Then you have to say, okay, which sections or which parts of mock I did not do well. So I didn't do algebra well or arithmetic well. Which parts were you struggling with? So then practice a lot of questions from those particular parts. So between mock, one mock to another, you should see small steps or small improvements in each of the sections. They will add up to considerable improvements. That would mean that if you get one more question right in each of the sections, that's plus 9 marks. So that way, those small steps will essentially get you the improvement, overall improvement that you will need. Always remember, focus on one small part of the portion. Say that, okay, you're not doing well in this topic, profit and loss. Do 50 questions from profit and loss, you will see the improvement. Okay, good to see a lot of people are joining in now. Okay, and I know a lot of people are nervous about CAT exam. One thing I'll tell all the students who are preparing for CAT exam and those who are anxious, those who are worried, remember that CAT exam is only one exam. There are multiple exams that you can take to get into a good MBA institute. After CAT, you have ZAT exam. ZAT exam will get you into a very good institute like XLRI. So don't think of CAT as the one thing that you have to do. That is the only thing, and that will create a lot of unnecessary pressure. Think that, okay, you have to do well in CAT, you have to do well in ZAT. There are multiple chances, multiple opportunities, and you're going to give your best in all of them. Don't create this unnecessary stress or pressure for the CAT exam. ZAT exam is also important. Those who are giving NMAT is also important. Those who are giving SNAP is also important. So these are there are multiple exams and you should prepare for all of them. Remember, ZAT is an extremely important exam along with CAT, and you should also be thinking that I have to give all of these different exams before I get into my dream institute. Okay. Okay, thank you, Sparsh. Thank you for the compliment. Will this session cover the PNC geometry related concepts too? No, we'll be focusing only on pure PNC over here. Basically, the concepts that are covered are basically the PNC formulae. We'll be revising them, we'll refresh all the formulae, and we'll try to make sure that you know exactly how to apply that so that all the formulas are fresh in your mind. Geometry covering we'll cover geometry in the next session. And overlap would be where both formulas will have to be used. You would know both formulas, and in case there is an overlap between geometry and PNC, you would know both formulas to actually use. Okay. How many marks to score 99 percentile in exam? Mohan, it's difficult to tell. I don't know whether you have seen Cracku's video, but one video that we made recently showed that the 99 percentile cutoff in CAT has been decreasing year by year. So I think last year it was near 70 marks or 70 marks or so. It is decreasing. It's showing a downward trend year on year. So with that in mind, what I would say is that we don't know what CAT 2024 is going to be like. But if it is a difficult exam as such, the 99 percentile marks would even be lower than CAT 2023. So don't index on marks, because the marks will actually adjust according to the difficulty of the exam. You should focus on your preparation. If the exam is difficult, you should still be able to get the required marks to get to 99 percentile. How many mocks to give in the last 17 days? Kiran, I would say that the max mocks you can give is basically every alternate day, and make sure that you analyze each mock. So basically one day give the mock, next day analyze the mock, next give the mock, analyze the mock. So max mocks that you should give without burning out or without getting like overly exhausted with mocks would be 8 mocks as such. How to choose set in LR? So I would say that I have my particular strategy, and I'll tell you the reason behind my strategy. Your strategy might be slightly different based on your strengths and weaknesses. In DILR section, what I generally look for is, the first thing that I look for is that, is there any charts based set? From my experience of taking CAT for the last 10 plus years, the charts based sets by default have always been the easiest sets. After that, I try to look out for if there is any 4-set Venn diagram based set, or if there is any charts based set, any set theory based. So after charts, set theory based sets are generally the second most easiest as such. After that, I try to see if there are any table based sets. After that, I try to see if there are any arrangement based sets. Then if none of these are there, then I will look at the other sets that are there. The other sets can be games and tournaments, scheduling, routes and networks. Generally, I feel my practice or the my experience lies quite a bit in charts, tables, set theory and arrangements based set. With games and tournaments, I'm worried that it might be a slightly more difficult than usual games and tournaments, and I can get badly stuck. Or if it is a slightly difficult routes and networks, it can be overly complicated, which will become a time sink. So generally, I look for those kind of sets which I know are generally on the easier side and which I am stronger in. So that is what you should look for. There are certain sets which are generally always on the easier side, and you should develop your proficiency in those sets. Okay. So we will be starting soon. I see a lot of people have joined us, but not that many likes. So I would request all those who have joined us, please like the stream, because it helps us quite a bit in reaching more students. It motivates us to hold more of these streams. So in this particular session, I'll tell you the format of the session. I'll cover a formula, I'll give a question based on it. I'll cover a formula, I'll give a question based on it. I want you to solve each and every single question that is there. So in this particular case, I want you to go to the session and make sure that you are seeing, go to cracku.in, make sure you are able to see the live session, cracku.in/live. I want you to be able to solve each one of these questions. So go to cracku.in/live. Okay. I want all of you guys to head over there. You can see the video also on the screen, but essentially below the video, whenever I post a question, you will be seeing in that same video, questions will start appearing. I want you to sit with a pen and paper. I want you to attempt each one of these sets. It is important to solve in the last few days before CAT. All the practice that you can get is very, very important. So make sure that you solve along with me. So please head over to cracku.in/live, and I want to see more of you guys there, and I want to see more of you solving as such. Okay. Okay. So Agarwal is saying, sometimes take me 15 minutes for a single RC, ma'am, what to do? So what I would say is that you need to improve your concentration and reading speed. Ideally, you should spend 5 minutes reading. That includes reading and writing down the main point. And then when you are actually solving the question, you have to actually not spend too much time solving or double guessing your answers as such. A lot of students spend like 5-10 minutes like picking the correct answer. Before you reach even the questions, before you see the options, you should have a very good hold or grasp of the passage. If you have a very good understanding of the passage, you will not get confused by the options. That is one. Secondly, if you are confused by the options, don't spend too much time just reading the options or trying to pick between them. The options will not help you. If you're spending like 1 or 2 minutes at each question as such, you are actually not using the time properly, because the options will not help you, the question will not help you. Where do you actually have to spend time? You have to spend time on the passage. So spend 5 minutes sharp. At 5 minutes, you should say that my entire passage reading should be over, the main point should be over, and 3 minutes I should focus only on the questions. If I am not able to answer a question, I should not take it on my ego, I should just leave it and go ahead. A lot of students keep just double guessing, is it A or C, and then spend like 5 minutes, 2 minutes on just one question. Just ignore it, go to the next question. That should not be the, on the question part, you should not be spending a lot of time, okay? How is 70 marks in Head Start mocks? They are good, that's a very good score, but I want you to do slightly better. Abhishek, that would be around 99 percentile as such. I want you to get to 99.5, try to get to 80, 85, that would be a very comfortable score for you to get many of the shortlist. Hello, ma'am, my average score of dash cats and Head Starts is around 75. Is it good enough? What can I do to improve it? It is good, Nandini, it is a very good score, but I want you to try to get it to 80, 85 before the actual CAT. Find out where you are not scoring well, which section you are not scoring well in. Try to improve in that section. Take a lot of sectionals, take a lot of practice tests. So I would say that in the last few days before CAT, just focus on solving questions. They can be in the form of mocks, they can be in the form of sectionals, and in practice tests. So what should you solve in terms of practice tests? All the topics which you are slightly weak in. If you don't have confidence in algebra, solve a lot of questions from algebra. If you feel that you don't have confidence in LRDI, take a lot of LRDI sectionals and keep taking mocks regularly. Mocks are the best way in which you can actually start seeing improvement. Between mocks, do the practice and sectional tests. Okay, good to see a lot of people have joined, and I'll be starting the session now. A small request to all those who have joined, please like this stream. It helps us quite a bit. And I hope all of you have headed over to cracku.in/live and are able to see the session there also. Just let me know if all of you are able to see the cracku.in/live session. And okay. Good to see. I think most people have come over here also. Hi Aniket, hi Rupali, hi Keval, hi Vidisha. How many mocks should I take from now on? You have mentioned. Try to take as many mocks as possible. At the max or the top end, you have 8 mocks taken every other day. 70 in Head Start, 45 in Dash Cats. How is the score? Try to push it up. 45 in Dash Cats, I feel you are slightly in the danger category. It would be slightly below 99 percentile. Try to push it up to 60. 60 in Dash Cat would mean 99 percentile in actual cat. What is the action plan that you recommend in these 15 days? Ankit, just focus on solving. Solve. Solve like crazy. This is something that I did personally in my own CAT attempt. Last 2 weeks before CAT, I was fortunate enough to get leave from my job. Basically, I just locked myself away. I started solving previous year's papers first. Then I started solving anything and everything that I could get my hand on. My idea was that I should go into the exam center with a lot of confidence, with a lot of practice. See, basically, if you start running, right, you get the kinks out of your running, you become more efficient in running. Similarly, if you go in the last week, if you solve a lot of questions, you will become efficient in solving, you will become fast in solving. So you have to get that momentum just before the final day. Okay, so good to see all those are revision videos enough to cover geometry. Yes, the revision videos, see, firstly cover the geometry concept videos. There's the geometry overview video. If you cover them, that would be completely enough to see all the parts of geometry. So concept videos plus overview video would be enough to cover entire geometry. If you are low on time, I would say just see the overview video. Overview video is a shortened version of the concept videos. Okay, so good to see all those who have joined. I'll try to answer more of your questions here, but I will get started with the PNC revision. I hope all of you are ready with your pen and paper. Anybody has any questions, please just keep asking there, and I will try to solve as many. I'll try to answer as many of your questions as possible. One thing that I'll mention for the person who asked what should be the last 15-day strategy. If you're looking for practice and if you're looking for guided practice, do check out Cracku's 100 quant questions. See, basically those marathons help you quite a bit. The ideal way to do that, marathon is to start, see the question, solve it yourself. If you're not able to solve it, see the solution. So in those 100 questions, you will cover the entire syllabus. You will get practice also, you will get concept coverage also. So that would be the ideal way in which you can spend a particular day for preparing for CAT. So definitely do check out Cracku's top 100 questions for Quant. Okay, so let's get started. Okay, everyone ready with preparing for this? What is in each section? Okay, constantly getting ratio of level 1, 2, 3, 4 in each section. I don't know whether you are asking about the difficulty of questions. See, basically most of the questions in CAT are in the moderate to difficult category. For the last few years, we have not seen easy questions in CAT at all. None of the sections were easy. Maybe VRC to an extent, but LRDI, no easy set, Quant, no easy question. So all, even in dashcats, you will see the same difficulty level represented, because this is something we saw in CAT 2022 and 2023. So let's get started. Okay, so let's get started with all the PNC work. So first thing, the basic formula for arrangement. If you have n items, the number of ways in which you can arrange n distinct items. Suppose the letters of the word water, how many ways can you arrange these letters? You can arrange them in 1, 2, 3, 4, 5 ways. So there are 5 letters, so you can arrange them in 5 factorial ways. 5 factorial is essentially multiplication of 5, 4, 3, 2, 1. This is the most basic formula. I hope all of you know this formula. This is the basic formula that whenever you have to arrange n distinct items, we have to find out in how many ways a particular 5 things can be arranged. It is n factorial ways. Now this becomes slightly more difficult when you have repetition of items, because if suppose instead of like say water, you had level, the word level. Now level does not have distinct letters, it has repeated letters. There are 2 L's and 2 E's. So if you consider the number of arrangements level can have, there will be fewer arrangements than water. Why is that? Because E and L are repeated. So whether you put this one E over here or this E over here, it doesn't matter. The end configuration would be identical. So that's why when there is repetition of letters, suppose one particular letter is repeated R times, you have to divide by R factorial. Suppose you have like 2 letters repeated over here, you have to essentially say that okay, without repetition it would be 5 factorial ways. Since L is repeated twice, I'll divide by 2 factorial. E is repeated twice, I'll divide by 2 factorial. In general, if there is no repetition, it is n factorial. If there is any kind of repetition, divide by the number of times of repetition. So if something is repeated A times, divide by A factorial. If something is repeated B times, divide by B factorial. If something is repeated C times, divide by C factorial, and so on. This is the basic idea of arrangement. Questions can come from this topic. Questions, if they come from this topic, will generally combine other parts of PNC as such. So I'll start with one easy question. Initially, I'll give some easy questions so that your confidence is also up. You get into the zone of solving, and then we'll take a look at some CAT level questions. So a very easy question coming your way. I hope all of you guys are able to solve it. Okay, and I'm giving only 2 minutes for it because it's a very easy question. RD is asking, I'm getting 25 to 30 in Cracku Quant sectional. How much can I score in actual CAT? That's a very good score. See, basically, Cracku's dashcat Quant sectionals are at the actual difficulty level of CAT. If that is the same difficulty level, if you get 25 to 30, that would be 99 percentile plus in Quant as such. If you consider, I think CAT 2024, that would be easily beyond 99 percentile in Quant. So that is a very good score. Keep at it. I want you to try to push. If I would guess that this would be your strength, if you're scoring that well in Quant, I'm guessing that is your strength. So try to push more to like 30, 35, because if it's your strength, you should really outperform over there. For me, my strength is VRC section. So I try to get in higher 50s or 60s in VRC because I really have to do well so that my overall score is high. For Maruti, Quant is his strength. So he tries to hit like 60 plus there so that his overall score is high. If Quant is your strength, I would say really try to hit 40s because then your overall score will also be high. Okay. Ishan, basically your VRC strategy should depend on your strengths and weaknesses. If your strengths are RCs, I would say that try to do at least 2 RCs before you go to VA. But otherwise, basically try to fine tune it based on your mock attempts, what actually works for you. See, the reason why people go between RC, BA back to RC is to relieve some kind of like reading stress that occurs. If you read a lot of RCs on one after the other, it kind of is stressful at times. So people tend to switch between RC and BA just to relieve that pressure or relieve that stress. But if it works for you, it works for you. There is no reason for you to actually switch that strategy to something else as such. Select a strategy that works for you. What works for me might not work for you. So fine tune that strategy by attempting a lot of VRC sectionals, by attempting a lot of mocks. You will know then exactly what works for you and what doesn't work for you. Okay, good to see a lot of people have gotten this right. Most of you have gotten it right. So very good. I'm sure all of you would know by now how to solve these kind of questions. It is a fairly simple question, but still let's take a look at it. A burglar trying to disarm an alarm system notices that 4 numbers on the keypad 3, 5, 6, 8 have faded more than the others. Guessing that these numbers are part of the 4-digit security key, he tries different combinations to break in. What is the maximum number of attempts he needs to disarm the system? See, if he is trying different codes, the maximum number of attempts that he would need would be the unluckiest case that the last guess is the right one. So you have to essentially figure out how many possible guesses that are there. So he will say that guess 1, guess 2, guess 3. The unluckiest case would be that the last possible guess would be the right answer, and then he would get into the safe. So you have to essentially find out how many guesses are there. So how many guesses are there? Basically, how many possible keys are there such that 3, 5, 6, 8 would be used in a 4-digit security key. Since 4 digits are there and 4-digit security key is there, that would mean that all 4 digits are used exactly once. So if all 4 digits are used exactly once, that would mean that these digits appear once. You have to arrange them in some order and there is no repetition. So this would be basically the formula would be n factorial, which is in this case, since there are 4 digits, it would be 4 factorial, which is 24. There are 24 possible keys and the worst case scenario is that he opens it at the last possible key, which is the 24th attempt. So the correct answer is option D, 24. Anybody has any issue with that, let me know. And I know this is an easy one, but even if there is an issue, just let me know. I'll try to explain it before we move on. So somebody is asking, for agriculture graduate, what is the minimum percentile for FABM and IMA? Mohammed, I'm not really sure of it, but I know that our team can help you. Just write a email to support@cracku.in. We'll research it and get back to you with a detailed answer. Okay, cracku@cracku.in. We'll get back to you with a detailed answer. Ma'am, how can we manage work and studies in these last days? I'm feeling scared as the exam day is getting close. So this is something that I know a lot of people are struggling with: anxiety, fear, stress. I want you guys to think of CAT as just another day. See, basically what I try to do is when I try to get nervous, I try to think that, okay, this is just another mock, okay, this is just another exam. If I try to think that this is like the most important exam of my life, I will struggle with it. I'll get nervous, I'll panic. So I never try to think of it as an important exam. The first time I gave CAT, that was in 2007. I did that. I basically did this thing where I said that, okay, I have to do really well in this particular exam. If I don't do well, my 1 year will be wasted, etc., etc. I panicked. In the first 20 minutes of CAT, I did not solve a single question. When I gave the exam again in CAT 2008, the year I actually got in, that time basically I was not thinking about the result. I was not thinking that will I get in, how important this exam is. I just was not thinking about anything at all. I was just focused on the paper, trying to do the best in the paper as such. And then I used to think that, okay, if this doesn't happen, I'll give that. If that doesn't happen, I'll give any other exam. I will not fixate or like say that this is it. This is the exam that I have to actually crack. So I would also say that in a way to like de-stress yourself, say that there's CAT, there is that, there are other exams. CAT is not be all and end all of things. Okay. So that is basically what I would say to myself if I was in your shoes to try to de-stress. Okay. So continuing. Let's go to the next part, which is selection. What is selection? If you have n objects, you have to select r of them. There are 20 members, you have to select 5 of them. If there are 10 candies, you have to select 3 of them. All of this is basically selection. In selection, the order of how you pick does not matter. For example, if you are selecting 5 people out of 20, In what order you actually pick them does not matter, because the committee that is formed at the end of the day will be the same. So whether you pick A, B, C, D, E in this order or E, A, B, C, D, it does not matter, because at the end of the day, the same committee is there. So this is essentially selection without arrangement, pure selection. So what is the formula for pure selection? This is represented as NCR. It is n factorial divided by r factorial into n minus r factorial. This is pure selection. There is no arrangement. You are just picking r items out of n items. Okay, everybody is fine. I will give the next question and I will answer the questions that you are posting. So try to do this one also, not a difficult question as such. I am scoring well in daily targets of VRC, but when it comes to mocks, I lose my consistency. Any tips to maintain the consistency in mocks? So Godwin, I would say that this is something that I see a lot of students do. Firstly, after so many times, when I have told so many of my students that do active reading, many of them don't do active reading. And I'll tell you where active reading actually makes a big difference. See, many people are very concentrated, very switched on in the first RC. In the first RC, they can actually solve the RC without doing active reading. In an actual mock, when you have to read 4 RCs, it becomes a struggle. So when you are doing the 15 minutes daily target, it is not really difficult for you to focus or be consistent in the first, like that 15 minutes, one RC set as such. But when you have to do it again for another RC and another RC, it becomes very difficult to stay focused. It becomes very difficult to concentrate. Then active reading plays a big role. So what I would suggest is that if you are somebody who does not like doing active reading, writing down the main point, at least with the second RC or the third RC that you attempt, at least then write down the main point, because then your consistency will be higher, then your accuracy will be higher. Otherwise, I see that if you see RCs attempted and accuracy, okay, this is accuracy, this is RCs attempted. I generally see for many of my students, first RC, very high accuracy, second RC, lower accuracy, third RC, it is just negative accuracy. By that time, you are scoring negative marks as such. So if this is happening to you, at least in the second and third RC, try to do active reading, because then your accuracy will stabilize. It will not fall down a cliff. If without active reading, it just falls down a cliff. So that is what I would suggest for those who are seeing a drop in their accuracy, seeing poor mock scores when their individual or practice test scores are good. Okay. So let's see how people have done. I think again an easy question. I know that most of you would get it. I'm starting up with some easy questions. I'll give harder questions after this. So as you can see, how many different teams of 17 members can be formed out of 20 persons? So in how many ways can you select 17 people out of 20 people? That is essentially 20C17. That is 20 factorial divided by 17 factorial into 3 factorial. So 20 factorial, 17 factorial, I remove the common terms. So I'm left with 20, 19 and 18. This into 17 factorial, I will cancel in numerator and denominator. So this is in the numerator and 3 factorial in denominator, which is basically 1 into 2 into 3. This I can cancel. This is 6. 6 times 3 is 18. So I have to basically say what is 20 into 19 into 3. So this is 20 into 57. So that would be 1140, which is option B. Easy question. Most of you would have gotten it. If anybody didn't get it, there is no shame in it. Just ask me, I'll try to explain it. Anybody has any issues, let me know, I'll try to explain it. Okay. I'll keep answering your questions, but I'll give the next part, which is NPR, which is selection and arrangement. See, you have NCR, which is selection, right? Now, after selecting R items, you arrange them, multiply by R factorial. If you multiply by R factorial, you get NPR, which is not just selecting R items out of N items, but also arranging them. So you select the items NCR into R factorial, which is arrangement of R items, you get NPR. And the NCR is basically what? This is N factorial divided by N minus R factorial into R factorial. Multiply this by R factorial, this cancels with this, and you get the formula for selection and arrangement, which is this. See, generally the steps that I do when I am solving permutations and combinations questions, which I try to subconsciously I try to do. If there are different cases that are possible, so case 1, case 2, case 3, just figure out what different cases that are there. Okay. Once you have figured out the different cases, do the selection part. how many cases, how many ways are there for selecting, into the arrangement part, how many ways are there to arrange the selected quantities. Case 1, selection and arrangement, total number of ways. Case 2, selection into arrangement, total number of ways. Case 3, selection into arrangement, total number of ways. Add them all up, you get the final number of ways in which a particular selection and arrangement can take place. This is the general format for all of PNC. PNC is nothing other than consider case 1, case 2, case 3, n number of cases where there are differences in arrangement styles. Then you say that, okay, in this particular case, these are the number of elements and they can be selected and arranged in this way. In this particular style, these are the number of elements, they can be selected and arranged in this way. Just do the case wise method, consider the ways of selection, consider the ways of arrangement. Selection into arrangement is total number of ways of case 1, total number of ways of case 2, total number of ways of case 3, add them all up, you get the final this. If you do this again and again, you will never go wrong in any PNC question as such. Okay, so let us why in previous one no repetition, why was there no repetition in this? So why is no repetition in which one? In the first one. Okay, why is there no repetition? It is 4-digit key, 3, 4, 3, 5, 6, 8, all are one. See, if there was any repetition, there would be only 3 keys or 2 keys or 1 key. The fact that there are 4 keys and it's a 4-digit security key means there is no repetition. Okay, so let's take a look at a question based on selection and arrangement. Not difficult, but not trivial anymore. The first 2 ones were very easy, right? This one is not easy. So make sure that you do this properly and get it right. Yeah, I will, Abhishek, I'll be covering that, don't worry. So that would be there next in the next slide. So don't worry, I'll be covering that also. Are Cracku's free mocks same level as CAT? Yes, they are. We basically make sure that we are coming as close to the CAT level as possible in terms of difficulty, in terms of weightage, in terms of type of questions, the wording, every single thing. We try to mimic CAT in every single way across the different years, what we have seen, what we have observed in terms of difficulty, in terms of the type of questions. We make sure that your experience with a dash CAT, with a free mock, with a head start mock is exactly the same as an actual CAT. Okay. One thing I'd like to tell all those who are trying to mug up in the last few days, how do I cover the entire syllabus? I would say that you can try Cracku's revision videos. Naveen has put in the revision playlist also over there. This is a very important playlist because it tells you all the revision videos that are there. In one place, you can revise the entire Quant syllabus, the entire LRDI types of sets that come, and all the VRC questions in one go. So if you are looking for one way in which you can cover the entire syllabus for all 3 sections, this should be the revision playlist you should definitely see. Okay, so RD asks, ma'am, I'm able to score 2 sets in LRDI. Good, that's a fairly decent attempt. 25 to 13 quants, very good. But scoring single digit in VRC, should I give up on CAT and shift my focus on SNAP and ZAT? ZAT will definitely not be your friend if you are finding it difficult in VRC. ZAT and SNAP would not be the ones I would focus on. See, if you are doing so well in LRDI and Quant, I would say that you have a very good chance even in VRC. What I would suggest is focus only on VRC at this point. You know you have Quant in the bag, you know you have LRD in the bag. Keep some practice, do like put 1-2 hours every single day for those 2 sections as such. But for VRC, just go all in. Solve sectionals, lots of sectionals. Do RC like RC tests, practice tests every single day. So RC tests are like 15 minutes. So anytime you get any 15 minutes, solve RC sets. Solve as many RC sets that you can possibly do before CAT. See, if you have the habit of reading, you will do well in VRC. If you don't have the habit of reading, you have to like quickly develop a habit of reading in the next few days. So the only way you can quickly develop that habit, quickly develop the comprehension skills is through solving RC sets. So solve RC sets daily. I would say if you are single digit in VRC doing so well in the other 2 sections, I do 5 RCs every single day and I do VARC sectionals every other day as such. That would get you up to speed with what is required for CAT. You can definitely clear CAT. Don't be defeatist in your attitude. You can definitely clear CAT, but you have to go all in with VRC. Okay. So good to see all those who have joined. One more last request from us, that those who have joined, please like the stream in YouTube. It helps us reach more students and it motivates us to do more of these streams. And another thing that I would like to say is that for those who are looking for revision videos, do check out revision videos, the playlist that we have put in the chat. And secondly, do check out Cracku's top 100 quant questions as such. These are excellent source for practice. They are sourced from all parts of the section. So if you are somebody who ignores a particular part of the like quant section, you'll be covering all of that also if you cover the 100 questions. Okay. And one more thing, those who are getting like very stressed out by the CAT exam, I'd say that there is also that exam. Think that okay, there are multiple exams that I'm going to give. There is CAT, there is that, and after all of that, I'm going to basically choose the best offer that I get. Okay, don't get stressed out by one exam. Okay, so let us take a look at how to solve this question. How many 5-letter words can be formed from the word moisture, such that, firstly, let me see how many people solved it. A good decent number solved it. Some people struggle, so let's see. So we can, I have mentioned, first do selection and then multiply by the number of ways of arrangement. Okay, that is the general format that we should follow. How many 5-letter words can be formed from the word moisture such that the letter M is always selected? So 5-letter words, so M is selected, all the letters are distinct, so there is no repetition, so that is very good. We don't have to deal with repetition, good for us. So M is already there. We have to select 4 other letters. So apart from M, how many other letters are there? 1, 2, 3, 4, 5, 6, 7. So from these 7 letters, we have to select 4 letters. So 7 letters, select 4 letters, the number of ways is 7C4. So 7C4 is the number of ways of selection. Now after selection has taken, so you have now 5 letters with you, all distinct. 5 letters, in how many ways can you arrange them? 5 factorial ways. So the total number of ways would be 7C4 into 5 factorial. Now I don't find anything which is 7C4 into 5 factorial. But definitely it is not 7C4 because 5 factorial is not equal to 1. This is not 7 factorial minus 4 factorial also, because 7C4 and 7 factorial are very different. But I see something which is close to my answer but not the quite the answer as such. It is 7C3. But the trick that you should remember is that 7C4 is 7C3. Why is this the case? NCR is equal to NCN minus R. Because if you expand this, what is NCR? It is n factorial divided by r factorial into n minus r factorial. Same way on the right hand side, you have n factorial, n minus r factorial, n minus r factorial, which is essentially r factorial. So those two things are equal. So 7C4 is 7C3. So the correct answer is option C. Okay. Anybody who got tripped up by this particular question, don't get flustered by it. Just say that, okay, how many ways can I select? How many ways can I arrange? Selection into arrangement is the answer. Okay. Let's go with the next part, which is another question. Here we have repetition. So last time I didn't give repetition question, right? So here I'm giving you a question with repetition. I want you to figure out how to do this. Pavas, which question are you talking about? Let me tell me which question so that I can explain that. Okay, Sagar is saying, I have my NMAT tomorrow. I'm feeling underconfident, need in yours and sir's blessings. They're always with you, Sagar, and I know that you have been very, very sincere. I've been seeing you come regularly to the streams. You will do well. You have put in the hard work. I know you are a very, very sincere guy. I'm fully confident. I am confident you will do well. So I know that you will do well. Just give your best. Make sure that you do justice to your hard work, your talent, and you will do extremely well in NMAT. Don't worry about it at all. You will do very, very well. Okay. Can we select M again? Q3. Okay. Sorry. This one. This one? Yeah. Can we select M again? No, we can't select M again. Basically, in the when you are making a 5-letter words from this such that M is always selected. Yeah, I think you should say that it should be, I think it should say 5 letters with distinct letters, because essentially otherwise you can say M also is there. So that is also there. Yeah, I think you are right. That should be mentioned. It is 5 distinct letter words that should be added. Correct you are actually, Pavas. Sorry, I missed that. See, in this case, it was not mentioned that the 5-letter word has to have distinct letters. If that is not mentioned, you can have 5-letter word, which is essentially MMMM also. So that is something that we had not considered. So it should be 5 distinct letter words which can be formed from the word moisture. So let us see with the this question. Okay, I think this is slightly difficult, but I want you guys to try to solve it. Okay, I'll give some more seconds so that you can solve it. Okay, let's, I think most of you would have solved it by now. I guess many of you found this difficult, many of you didn't attempt it, but this is not a difficult this at all. See, basically what I mentioned is that when you are any kind of PNC question, what should you do? Form different cases, selection into arrangement is the total number of ways. So how many 4-letter words can you form with the letters of the word elementary? So basically you have to assume that, again, as was with last question, in such cases you are assuming that the letters are taken only once. So when you say you take the letters, essentially you can't repeat the same letter. When you are doing selection of this, you are not allowed to repeat. That is implicit in many questions, but as Powers mentioned, we can read it another way. But when you say that, okay, letters from this word, it generally means that you don't, in selection you don't repeat. Okay, over here also in selection you don't repeat. Here, because there is repetition of letters, E is only coming many times, you can then assume that you have access to multiple E's. So let us consider how many letters are there with us. So you have, so 1, 2, 3 E's, then you have L, M, N, T, A, R, Y. So 7 distinct letters and 1 letter which is repeated thrice as such. So if you are taking letters and forming a 4-letter word out of this, what could be the 4-letter word? See, one way is that you consider a 4-letter word such that all 4 letters are distinct as such, 4 distinct letters. This is case 1. Okay. Second case is basically you have consider that E, you have 2 E's, that is the repeated letter. So you have 2 E's and then 2 distinct letters. So essentially there is 2 repetition of 1 letter which is coming twice. Or you have the case where you have 3 E's and then 1 letter from the remaining 7. So that means that there is a repetition of 3 letters, okay, 3 letters repetition. These are the 3 cases that can happen, okay, when you are taking letters from that and forming a 4-letter word, given that there is repetition of letters, these are the 3 different cases that can occur. So I have written case 1, case 2, case 3. So let us consider what is the ways of selection, arrangement and total number of ways for each one of them. Selection, arrangement, total number of ways. So in how many ways can I select 4 distinct letters from these letters? So if I am considering only 4 distinct letters, I will consider these 8 letters as such. From these 8 letters, I have to select 4. So that would be 8C4 ways. Okay, so from these 8C4 ways, I have to arrange them. If I arrange them, what would be the number of ways as such? The number of ways if I make 4-letter words, basically I will select them in 8C4 ways. And how many ways can I arrange them? Since each of these letters are distinct, that would be 4 factorial ways, sorry, not 8 factorial. There are 4-letter words, so this would be in 4 factorial ways. So the total number of ways or total number of this would be 8C4 into 4 factorial, which is essentially 8P4 as such. This, you have 2 E's in this. Okay, if you have 2 E's in this, E's are already selected. I can select 2 other letters from the remaining 7 letters. That I can do in 7C2 ways. How many ways can I arrange it? Since there is repetition, total number of arrangements is 4 factorial. Since there is repetition of 2 E's, I have to divide by 2 factorial. 7C2 into 4 factorial by 2 factorial will give me the total number of ways. If there are 3 E's in it, I have to select 1 letter from the remaining 7. So that I can do it in 7C1 ways. How many ways can I arrange this? I can arrange this in 4 factorial divided by 3 factorial ways because there is repetition of 3 letters. So total number of ways would be the product of these two. So let us figure out the product and the value for each one of these cases. 8 factorial into 8p4 would be basically 8 factorial by 4 factorial. So it would be the product of 5. So first case 8p4 would be how much? It would be basically 5, 6, 7, 8. This is 8p4. So this is 30, 210 into 8 would be 1680. So this would be 1680, the product of these two. The product of these two would be how much? 7c2 would be 7 into 6 by 2. So 7 into 3, so that is 21 into 4 factorial by 2 factorial. So that is 3 into 4. So 3 into 4 is 12. So this would be 210 plus 42, 252. This would be 7 into 4. This is just 28. So add this all up. 28 plus 252 is how much? It is 280. 280 plus 1680 is how much? It would be 1960. So the total number of words that can be found is option A, 1960. Okay. Anybody who had, because it's 7 in this. Why was it 8c4 for the first case? No, it is not 7 in next two cases. See, 8c4, it was 8c4 in the first case because I am not considering always that E will be selected. So I have how many possibilities? I have 8 possibilities over here. E, L, M, N, T, A, R, Y. Here I am considering that no E is also selected. That is also a possibility as such. So it is essentially a combination of 2 possibilities. 0 E is selected, so that is 7 factorial 7C4 letters. Plus 1 E is selected, which would again mean that that one extra letter is possible. So essentially it is 8C4. There are 8 possibilities. I select 4 of them. So that is why 8C4 is the number of cases. When I consider E is already there. 2 E's are already there. I am not selecting the third E over there. So E is already there. The remaining 7 letters will give me the 2 letters that are not E. So that is basically when I split it up into cases. The first case is 0 E or 1 E. So that would be 8c4 into 4 factorial or 8p4. The second case is basically 2 E's and 2 distinct letters. So for those 2 distinct letters, I can select it in 7c2 ways. The third case is 3 E's and 1 distinct letter. So that one distinct letter I can select in 7c1 ways. Okay. E is not possible because there are 3 E's. See, generally when you are saying, okay, 4 letter words from the letters of the word, use the letters of the word. It is implied that you do not repeat the letters of the word. This is something that is we have seen in the wording of CAT questions again and again. As Powers had asked earlier, can you actually use M again and again? While it was not explicitly mentioned, you should explicitly mention, okay, distinct letter words and all. Even if it is not explicitly mentioned, whenever you are actually forming another word from a word that is already given, you are supposed to use the letters only the number of times it is there in the original word. So if 3 times E is there, you are limited to use it only 3 times. Okay. Okay, this was a tough one, I know, and I gave it specifically because I want you to get into this habit of consider cases, number of ways of selecting, number of ways of arrangement. Selection into arrangement is the number of ways. Add it all up, you get the answer. This is basically how you should solve these kind of questions. Okay. So next part, let us go with partitioning. Partitioning is the difficult part of PNC. Generally, a lot of students struggle with it because it requires a lot of abstract thinking. So I'll try as much as possible to explain to you why something is occurring and what is basically what choice is being made in each case. So what is partitioning? Partitioning is the process when you are asking how many ways can this be distributed, or in how many ways can these chocolates be given to these people, or in how many ways can balls be distributed in these urns, whatever is given. But the idea is basically you are distributing n items into r slots or r trays or something like that. Now let's consider you are distributing n items, distinct items in r boxes. It can be r boxes, r people, r bags, it doesn't matter. The idea is that they are containers such that the order doesn't matter. So if you are considering, okay, where does order matter, where does order not matter? So if you are saying that I gave 5 chocolates to Isha, so whether I gave Milky Bar first, whether I gave Perk first doesn't matter, because at the end of the day, only what she got matters. So their arrangement doesn't matter. But on the other hand, if you are putting like rings in a finger, so which finger should I put in? Here order matters. So we will consider the first case where you are distributing n distinct items in R slots where order doesn't matter. Now suppose you have these 4 slots in front of you, and suppose you have different colors balls or different books, okay? You have like geography book, history book, maths book, social sciences book. So in how many like boxes can the geography book go? It can go in 4 boxes. So you can take the decision in 4 ways. History book again can go in either of the 4 boxes. So that arrangement can be done in 4 ways. Maths can also go in 4 boxes. In one box you can put all 4 this also, that is also a possibility. So each one of these you have 4 choices for each book. So the total number of possibilities would be 4 into 4 into 4 into 4. So whatever is the number of slots, each of those items will get that many possibilities. So for n times, for n each of those n items, you will say that first item has R choices, second item has R choices, third item has R choices. This is for n times. So that would basically mean that the total number of choices is R raised to n. When there are n distinct items in R boxes, the total number of configurations is how much? It is R raised to n. The second question is n identical items in R boxes. So here you had geography book, history book, maths book, social sciences book, different subjects, right? Suppose it's not different subjects, it's not different books. So suppose you have 4 slots, and suppose you have like perk candy, you have four perk chocolates. Now whether it is perk chocolate here, one perk chocolate here and another perk chocolate here, is there any difference? Because they are identical perk chocolates, right? You won't be able to differentiate between who gets which perk chocolate. So when there are identical items, the number of ways of arranging or the number of choices becomes lesser. So in such particular cases, the formula that we generally say is that we consider this as we are distributing n identical objects among R slots. This can be done in n plus R minus 1 C R minus 1 ways. This is the same formula when you have linear equations. Somebody asked me, okay, linear equations, how do you actually find out the number of possible integral solutions? This is the exact idea. See, the idea basically is that suppose you have, like if you have R boxes, okay, say 4 boxes. Suppose this gets A number of chocolates, this gets B number of chocolates, this gets C number of chocolates, this gets D number of chocolates. So A plus B plus C plus D would be equal to how much? This is the total number of chocolates, which is n. So therefore we have to find out the number of integral solutions for 4 variables such that these 4 variables add up to n. So over here also the formula is the same thing. We consider the number of identical objects n plus the number of variables R minus 1 C R minus 1. This is basically when you can even distribute one object, when you don't care whether the object this is when you can even give 0 objects. So basically you don't care that somebody gets, it's not that okay every person has to get 1 candy. If somebody can get even 0 candies, A, B, C, D, if they can even be 0, then the number of possibilities is this much. But suppose if it is given that everybody should get at least 1 chocolate, or A, B, C, D are natural numbers. If it is given A, B, C, D is natural numbers, that means that none of these can be 0. Then and there itself you can say that okay, you cannot have a case where somebody gets 0 chocolates or 0, the value of any of these variables is 0. Then basically the formula is n minus 1 C R minus 1. We begin by doing, what do we begin by? We begin by first giving 1, 1, 1 to each one of them. So since there are R objects, we are removing R from the consideration. So now we are left with n minus R items which we can to distribute in R slots. So the number of ways of distribution would be n minus R plus R minus 1 C R minus 1. So this becomes essentially n minus 1 C R minus 1. Remember these two formulae, they are extremely important. When you are either number of integral solutions, you have say a equation with R variables adding up to n. The number of integral solutions would be n plus R minus 1 C R minus 1. If you have to give at least one value, or the number of the variables can take only natural numbers or something like that. So A, B, C, D has to be at least 1. The number of integral solutions becomes n minus 1 C R minus 1. This is what you have to remember. Both formulas, these two formulas are the most important in partitioning. This rarely comes. This comes always. When you are distributing n identical items in R boxes, n plus R minus 1 C R minus 1, mug it up. When you have to give at least 1 to every single R box, then it is n minus 1 CR minus 1. Mug it up. This is something that will come again and again and again and again in CAT. This is one of the most important parts of PNC. Okay. So based on this, I'll give you a question. So I hope most of you are able to solve this one. I given slightly more time on this one because no, I given 2.5 minutes also. So again, this is not difficult, but I want you to like think what should be the like work around for a slight complication that is given. It is given that it should be an even natural number. So what should you do in that case? I want you to think and find a way out. Can you repeat the last one? Okay, the formula. Okay, sorry. So remember, when n distinct items are put in R objects, R boxes, it is R raised to n. When you have n identical items, so basically n chocolates in R boxes, the formula is n plus R minus 1 CR minus 1. The derivation for it is difficult. I can explain it, but it will be just unnecessarily time consuming. Basically, just remember that when you have to distribute in R boxes, say 4 boxes, okay, and you have 4 variables A, B, C, D, okay, and you have say 10 items. In how many ways can you do it? You can say that if I have 10 items, I have to distribute in 4 boxes. I will start by saying 10 plus 4, that is the number of boxes I have to distribute in, minus 1 C 4 minus 1. This is the total number of ways I can distribute 10 identical items in 4 boxes such that the value can even be 0. I don't care whether everybody gets at least 1. Then it is this value, which is essentially 13C3. Now suppose you have 10 items, but everybody has to get at least 1. When you are told, okay, A, B, C, D are natural numbers. So then you will say that, okay, I will start off by giving 1 to every one of them. So by start only, I will say that, okay, there are 10 items, 4 boxes, let's place one item in each. I am left with 6 items. Now the 6 items, I will do the same thing. 6 items, 4 boxes, 6 plus 4 minus 1 C4 minus 1. So I am actually left with 9C4 in this particular case. So if I have to give at least 1 to everybody, it is 9C4. If I can give whatever I want to all of those 4 people, sorry, this is 9C3. If I can give whatever I want to all those 4 people, it is 13C3. Okay, this is the basic formula. I hope you guys are solving the question. This is easy question only. I see many people are able to solve it. Good. I'm happy that many of you were able to like overcome the small trick that was put, that it has to be an even natural number. What should you do in that particular case? Okay, I think most of you have been able to solve it, and yeah, very well done Aditya, VVC, Nipun and Balakrishnan. You have solved all of the questions and very well done. Keep at it. Okay. So let us take a look at the question. In how many ways can 16 identical chocolates be distributed among 5 children such that the number of chocolates with each child is an even natural number? So you have 5 children, A, B, C, D, E. Suppose these are the chocolates each of the child gets. So A plus B plus C plus D plus E is how much? That is equal to the number of chocolates that are given. Now the additional condition is that A, B, C, D, E are even natural numbers. That means the least value it can take is 2. So let us say that if it's an even natural number, say that A is essentially 2 times A dash, B is 2 times B dash, C is 2 times C dash, T is 2 times D dash, E is 2 times E dash. So the sum, this sum is equal to how much? This is equal to 16. So what is A dash plus B dash plus C dash plus D dash plus E dash equal to? This will be divided by 2, which is 8. Now how many possible integral solutions are there for this? Each one of these can take only natural number values because it is an even natural number. They can't be 0. So the total number of solutions would be 8, that is the number of objects that I have to distribute, minus 1, C, number of variables that are there, that is 5, minus 1. This is the total number of solutions. So this is 7C4. How much is 7C4? 7 into 6 into 5 divided by 3 factorial, which is 6. This cancels with this, you get 35. So what is the answer for this question? It is option A, 35. Anybody has any problem with this question? It's not a difficult question, but this part over here, that even natural number might have tripped up a few people. But if you write down the equation, you use the equation method, you will be able to overcome any small such issues as such. So write down the equation, make sure you express it in the form where you can directly apply the formula after that. Okay, so I converted it to this form such that I can then directly apply the formula n minus 1 c r minus 1. Okay. Kindly explain n minus 1 c r minus 1. Okay, see, basically you have the formula I explained is n plus r minus 1 c r minus 1, right? Now suppose you are at least for each of those r people, okay, you have to give at least one to them. So what you will say, that I have n chocolates, from this I will take out r chocolates, give each one of them one chocolate. Now I am left with n minus r chocolates. Now I can distribute these n minus r chocolates any way that I want. There is no more restriction. So I will say this is n minus r, that is the number of chocolates I am left with, plus the variable r minus 1 c r minus 1. This cancels with this, I get n minus 1 c r minus 1. This is basically what you have to do. Why didn't we use the second formula? We use the second formula, that is n minus 1 c r minus 1. How do you get this n minus 1 c r minus 1? Only what I was explaining, that when you have to give at least one, you can't give 0 things, then you have to use this formula. When you can give 0 things, when you are distributing to these 5 children and you can tell one child I am giving you 0, then you have to use this formula. But you are told even natural number. Natural number means it can't be 0. So that's why you have to use this formula in this case. Okay. I'll go to the next question. Anybody has any issue, let me know. I'll go to the next question. This is something that you would not normally think is about partitioning, but it is a partitioning question. Think about it. Okay. Normally you would not think that this is a partitioning question. I think this is an easy question. Now that I've told you it is partitioning, this should be fairly easy, but let's see. How many questions do we have? I think we have 1, 2, 3, 4, 5, 6, 7, 8. So we are at the 6th question out of 8. It should not be more, we will not overflow the time limit by much, but I want to give you every single example that I can, revise every single formula and give all examples of every formula so that it is fresh in your mind. I think most of you will be able to answer this. Yeah, most of you are getting it. Very good to see. Okay. See if there were any questions that I missed. So Shubham was asking, ma'am, why did we use second formula? So as I mentioned or I explained to those, we have to give even natural number, which means 0 is not a possibility. So you have to give at least 1 to everyone, at least 2 to everyone, because it's an even natural number. Therefore, we use the second formula. Okay, I think most of you have been able to answer this. Good to see a lot of people have been doing this. Ma'am, please do similar kinds of stream for VRC, so it would be helpful for many. Yes, we'll be doing a VRC full revision also, don't worry about it. We will be trying to revise the entire syllabus, Quant, LRDI, VRC, everything. What LOD can you expect in Quants this year? Please tell. See, basically what I have been seeing for the last few years is that the level of difficulty in Quant is creeping up. It was creeping up in 2019, 2020 slightly tougher, 2021 slightly tougher, 2022 slightly tougher, and then it just went crazy difficult in 23. What I feel is that 2024 it will be difficult again, but I don't think it will be as difficult as 2023. I think 2023 they kind of overdid it. So maybe it will be difficult, but not as difficult as 2023. That is my hope. Maybe I'm being wishful thinking, but I felt that they were slightly pushing the envelope and suddenly like they went too far with 2023. I don't think it will be that difficult in 2024. Okay. So mostly I will be explaining all the formulas that are there in PNC, all the topics that are there. I'll be covering everything. Okay, so I think most of you were able to solve. Some of you didn't understand how this is partitioning. So let me try to draw it out for you. Elixir Education went to campus placement process where they shortlisted 20 students for the final round of interviews. Given that there are no restrictions to how many students they can hire, what is the number of possible outcomes for the recruitment process? So there are 20 students. These are distinct students. A student is not identical. No A, B, C. They are different people. So you have N which is distinct. But there is no R slots. What are the slots over here? There is only like hired or no hire. So you can assume that there are 2 slots. This is the hire slot, hired. This is not hired. And there are 20 distinct items which you can put in either of this slot. There is no restriction. It's not that you have to hire at least 5 people or you can at most hire 3 people. Nothing, no restriction like this. There is no restriction. You can hire 0 people or you can hire all 20 people, which means that for each of these 20 people, there are 2 choices, hired or not hired. For the first person, 2 choices. For the second person, 2 choices. For the third person, 2 choices, or so on 20 times. So the total number of possibilities is how much? 2 raised to 20. Which is option D. A bit difficult. See, it was so trivial, okay? Once we actually say that this is about partitioning into 2 boxes, you could find the answer in like less than 30 seconds. So it is not a difficult question, but a very conceptual question. This will make sure that your concept of partitioning is very, very clear. Whenever a box is also not given, but 2 results are given, you can consider them as boxes. So this is also something that you should consider, that partitioning might not very obviously be partitioning, but it would be applying partitioning methods as such. Okay. Okay. So, ma'am, I belong to engineering background. I am confident in algebraic and arithmetic. I am reading every day and preparing for VA and solving some LRDI sets. Very good, Shubham. See, if you know you are at an advantage in arithmetic and algebra, keep at it. Become very good at arithmetic and algebra. When it comes to VARC, if you have any weak part in LRDI and VARC, focus on that in the last few days. See, idea should be that you clear all sectional cutoffs, and in whichever section is your strongest section, you do very, very well in that. So basically you become like 99.5 percentile in your strong section and at least a 95 percentile in the other 2 sections as such. Then you will have a high enough score overall. Okay, that would be the ideal attempt. Ma'am, what should have been the case when at least 1 student should have been hired? Then basically what happens is that you have to then say that you remove the case where 0 people are hired. So you say -1. So 2 raised to 20 minus 1 would mean that at least 1 person is hired. Okay, that is the answer, quick answer for at least 1 person hired. Then you say only at least 2 people hired. Then you say that, okay, in how many ways can you hire exactly 1 person? In how many ways can you hire exactly 2 people? So you remove all the negative cases to get the correct number of cases. Okay, let's go to the next question. Okay, partitioning with arrangement. So I had mentioned earlier when we were partitioning in distinct boxes, the arrangement did not matter. But suppose the arrangement does matter. For example, if you have, instead of boxes, suppose you have these pegs, okay, and you have n distinct rings. So you have a blue ring, you have a green ring, you have a red ring, and you have suppose like 4 pegs, peg 1, peg 2, peg 3 and peg 4. Peg is basically like a slot in which you can put a ring, or like a finger you can put ring 1, 2, 3. So here if you consider a finger, a blue ring, then a green ring and then a red ring. This arrangement is different from a blue ring being at top, green ring being in the middle and a red ring being at the bottom, because in a finger the arrangement of the rings also matters. So that basically means that when you are partitioning and in that partitioning also you are arranging, then the formula is slightly different. It is then not r raised to n, but the formula is this n plus r minus 1, r minus 1. So where are these formulas coming from? What is the instinctive reason for this formula? I'll try to explain in some small example so that you understand where it is coming from. So let's consider this example of like say 4 fingers or 4 pegs, P1, P2, P3. So P1, P2, P3 and P4, and our 4 rings, which is say blue, green, red and yellow. So there are 4 rings and we have to distribute them in these particular 4 pegs. So let us say that the division between these 4 pegs are these 3 lines. These 3 lines or ones as such are the divisors. And then we have our rings also. Say suppose this particular peg gets this ring, this particular peg gets this ring, this particular peg gets this ring. So in how many ways can you arrange this? See, basically the divisors are 1, 1, 1, and then you have B, G, R and Y. Okay, how many ways can you arrange this particular string of letters? The ones are repeated, B, G, R, Y are distinct. So the n items are distinct. And how many divisors are there? If there are R slot, there will be R minus 1 divisors. So R minus 1 partitioning divisors, they will be repeated. So in how many ways can you arrange them? You can arrange them, since there are a total of n plus r minus 1 items, they can be arranged in n plus r minus 1 factorial ways. But since r minus 1, the divisors are repeated, you have to divide by r minus 1 factorial. This is basically when you have partitioning with arrangement, you will say that okay, the n distinct items are there, then there are r minus 1 divisors, they can be arranged in n plus r minus 1 factorial ways divided by r minus 1 factorial ways. Okay, this is the formula when partitioning is there with arrangement. The question that I have chosen for it, you can't directly apply the formula, you have to consider case by case method, but if you consider case by case scenario, you will be able to answer the question. It is a slightly difficult question, direct application of formula is not possible, but if you use case by case method, you will be able to solve it. So let's take a look at that question. I've given you 3 minutes because it's a slightly tougher question. Okay. Piyush is saying, I'm getting the main point but not able to get the answers. Correct, in LRDI I'm able to solve one set but struggling with charts. So Piyush, what I would say is that if you don't have a direct intuitive sense for charts, find in charts, find in LR or DI something that you are good at. So you might be better with tables. Some people are not visual like thinkers. There are some people actually prefer numbers. So if you are better with tables, choose the sets which have tables in it or which require tables to be created, because there you might actually be strong in those kind of sets. When it comes to RCs, what I would say is that if you are getting main point, it is very good. Keep practicing. See questions, there might be specific traps which you are not able to find. So what I would say is that see the videos that we did a live session on distortions. So see the type of traps that we generally said and make sure that you understand, okay, this is a type of distortion paper set has put to trap students. So if you go through that video, then maybe your accuracy will improve, at least your ability to find a trap or see a trap will improve. Okay. So Khushi is asking, I scored 51 in Cracku's pre-mock, how much can I expect? Khushi, it's a decent score, but it is slightly on, I would say this is something that you have to build upon. This won't be a score that would get you many shortlists in actual CAT as such. So what I would suggest is that start building on this 51 score. See in the actual mock where you actually missed out on opportunities, which section did you not score well in. Try to attempt sectionals of that particular section, or try to attempt practice tests on any of the topics that you actually struggled with. Then you will see that that score will improve. An ideal score I would say would be around 70 to 80s. 70 is a slightly safe on the edge as such, but 80 plus is a very good score for both the free mocks as well as actual dash cats as such. Gitanjali is asking, madam, I'm losing focus on studies, what to do? So what I would say, Gitanjali, is that there are very few days left to CAT. You have to remind yourself that it is not a long journey in front of you. It's a short journey. You have to only focus for the last few days. Essentially, there should be nothing more important than preparing for the last few days. whatever else is disturbing you, is distracting you, say that okay, I will look at it, I will think about it after my cat is over. Till then I will focus only on cat. Just try to remove any other distraction, because cat is very near as such. Okay, and again, cat is not be all and end all. Remember, for all students, I want to remind, make sure you also apply for that. That is a very, very important exam. It is something which a lot of students, good students, overlook, and XLRI is such an excellent institute that you should definitely give that. Okay, let's see how people have done in this particular question. So I think a lot of people struggle with it, and I can understand, because this is a difficult question. I know that these kind of questions will come in CAT, and it will be time consuming also to solve. This is not a very easy question as such. So let's see how to actually solve it. So there are 8 steps from ground floor of a building to the first floor. A person can climb either 1 step at a time, 2 steps at a time, or 3 steps at a time. What is the total number of ways in which a person can climb the stairs to reach the first floor from the ground floor? Suppose he takes 1 steps, A 1 steps, okay? Okay, he takes suppose B 2 steps, and suppose he takes C 3 steps. Therefore, the total number of steps is just 8 steps. So 1 into A plus 2 into B plus 3 into C is the total number of steps, that is 8. That is the first thing that you can see. So we have a linear equation. Again, we have to find out the integral solution for this. What can be the values of A, what can be the values of B, what can be the values of C. But we can't directly apply the formula over here. Moreover, this is not just n identical items in R slots. Why is this not the same? Because even the arrangement matters. For example, if you took for the 8 steps, suppose you took 2, 3, 3 steps. This arrangement or this way of actually climbing up the steps is different from 3, 2, 3. So this is not just n identical in R slots. This is partitioning with arrangement. So if it is partitioning with arrangement, we have to see how to actually arrange. So again, we have to go case by case method, number of ways into arrangement. Okay, case 1. See, first thing that you see is that C is multiplied by 3 and 8 is a fairly small number. So we will start with the case that C is 0. Then A plus 2B is equal to 8. Now what are the possible integral values for A and B? A is equal to 8, B is equal to 0. A is equal to 6, B is equal to 1. A is equal to 4, B is equal to 2. A is equal to 2, B is equal to 3. A is equal to 0, B is equal to 4. This is one case scenario. In how many ways can you have, if A is equal to 8, all are ones? In how many ways can you arrange the ones? 1, 1, 1, 8 times. These can be arranged in only one ways, because all of them are just ones, it doesn't matter. Suppose you have 6 ones, 1, 1, 1, 6 times, and 1, 2. How many ways can you arrange it? This is 7 factorial by 6 factorial, so the number of arrangements becomes 7. You have 4 ones, 1, 2, 3, 4, and 2 twos. So total number of arrangements would be 6 factorial divided by 4 factorial by 2 factorial. So this is 6C4 essentially. 6C4 I can say it. 6C4 would be 5 into 6, 30 divided by 2. So this would be 15 as such. This would be 2 times 1 and 3 times 2. In how many ways can you arrange this? This would be basically 5 factorial divided by 2 factorial into 3 factorial. So this would be 5C3, which is 20 divided by 2. So this would be 10. Okay. How many ways can you do that? This is just 2, 2, 2. There's only one way to arrange. So this is 1. Okay. So this case when C is equal to 0, how many ways can you arrange all the values? This is 8 plus 15, 23, 33 plus 4, 34. So when C is equal to 0, that is there is no 3 step, there are 34 possibilities as such. Now let's consider when case 2. So case 1, when C is equal to 0, I found 34 possibilities. Case 2, C is equal to 1. So A plus 2B is equal to how much? 5. So in this case, A is equal to 5, B is equal to 0, A is equal to 3, B is equal to 1, A is equal to 1, B is equal to 2. These are the 3 possibilities that you can possibly have. Okay. So in this case, let us see, you have basically 1, 3 and 5 ones. In how many ways can you arrange all these string? It would be essentially 6 factorial by 5 factorial. So 6 ways. You have in this case 1, 3, 3 ones and 1, 2. How many ways can you arrange it? 5 factorial divided by 3 factorial. So that would be 20. This would be 1, 3, 1, 1 and 2 2s. So 4 factorial divided by 2 factorial. So this would be 12. So the total number of ways would be how much? This would be 26 plus 12. So this is 38. Case 3. C is equal to 2. A plus 2B is equal to how much? A plus 2B. This is 6 left with only 2. So A plus 2B is equal to 2. In this case, the possibilities are A is equal to 2, B is equal to 0, or A is equal to 0, B is equal to 1. So if A is equal to 2, C is equal to 2, we have 2 3s and 1 1. Number of ways of arranging this would be how much? 4 factorial by 2 factorial by 2 factorial. So that would be basically 12 divided by 2. So that is 6. This you have 2 3s and 1 2. Total number of arrangements would be 3 factorial by 2 factorial. So that is 3. So this total cases is 9. So I found 34 in the first case, 38 in the second case, 9 in the third case. I add them up all together. How much do I get? This 2 is 72 plus 9 is 81. So the correct answer is option A, 81. Difficult question. I know that this was a slightly difficult question. Would be difficult to do. How you took 8 as the total steps? There are 8 steps from the ground floor of the building to the first floor. So that is given already. Okay. So this is basically this 8 steps. So basically the sum of 1 steps plus the sum of 2 steps plus the sum of 3 steps should add up to 8, because that is the total number of steps you have to climb. Okay. This can also be taking f is equal to 1, f is equal to 2, Fibonacci series. Maybe, but I have not thought about it as a Fibonacci series. I'll think about it, Shrihit. I'm not really sure. I only thought about it in this way, but possibly there is another approach to it. I'll actually think about it and let you know later. Okay, so I will put the next question, which is circular arrangement. Circular arrangement is super simple. If you are able to solve it, it is very, very easy to do. The idea of circular arrangement is that in circular arrangement, if you fix one person, so if this is arrangement around a circle, you fix one person, the remaining n minus 1 people can be arranged as linear arrangement. So in circular arrangement, basically one person has to be fixed at some spot. There are essentially n axes of symmetry. So basically you consider linear arrangement, which is n factorial, right? You divide it by n, you get circular arrangement, because essentially if you say that circular around a round table, there is no, if you consider a line, okay, 1, 2, 3, 4, 5, 6. So essentially when you are arranging in a line, there is one end, leftmost end, rightmost end. Those ends are not there as guides in a circle, because in circle, whatever way you arrange, essentially it becomes the same arrangement. Whether you start from here, start from here, start from here, it doesn't matter. So there are n equal positions to start from, and then once you have placed one person on one position, then the remaining people can be arranged with respect to this one static position as such. So that's why in circular arrangement, the number of arrangements are, basically if you are arranging n people around a circular table, the number of arrangements become n minus 1 factorial. So with that, let us try to solve the question. This is an easy question. I expect all of you to actually solve it. How did you take 5 ones and so on? So basically over here, if I go back to that question, see basically over here when you say A is equal to 5, A is equal to 5 means 5 1 steps have been taken, C is equal to 1 means 1 3 steps have been taken. So I represent it as 1 3 and 5 ones, okay. And then how many ways can I arrange it? Okay, I can take the first step as 1 step, then take the 3 step, then take the remaining 1 steps. So I can arrange it in different ways. So basically you say that, okay, this is the scenario, this is one case, then these are the possible number of arrangements. Consider each scenario, then find the number of arrangements. Where did I get the 5 ones? This A is equal to 5. A is the coefficient of ones, B is the coefficient of 2s, C is the coefficient of 3s. So that's where I get the number of ones from. Okay. Why does the formula not apply to r raised to n formula cases? These cases are completely different. Yeah. So if you ignore arrangement, it is r raised to n. So for example, if you have like a bucket, okay, you're putting balls in a bucket. Arrangement doesn't matter, it is r raised to n. But if arrangement matters, so for example, if you are putting either rings in a finger, so if rings in a finger are there, in what order you put the rings, that also matters. Then you have the n minus r plus n plus r minus 1 factorial divided by r minus 1 factorial. This, remember this formula, this is much greater than r raised to n, because here you are only doing the putting of selection part, you are not doing the arrangement part. This part is selection and arrangement, so that will be greater. The number of cases would be greater in the first case than the second case. Okay. Okay, I hope most of you are able to solve this. I see that most of you are able to solve this. So hopefully we'll get done with in this particular this. For all students who are actually watching this stream, I'd like to remind those who are studying for CAT, please follow us on our Instagram page, because we keep giving important exam updates, especially now because application deadlines are coming up, exam dates are coming up, the last dates to apply are very, very critical. So do follow us on Instagram page, because we keep updating there. I don't want any of you to actually miss out on applying for an exam because you didn't know it was the last date to apply and so on. So do follow us on Instagram. We'll make sure that we keep on giving you all the notifications on time. Okay. Okay, let me see how people have done. I think this was slightly challenging for some people because there were these additional conditions, no direct application of formula. So let's see how to actually solve this. Okay. So in general, remember that when an extra condition is given, so suppose that these are the number of total possible cases. Okay. And if an extra condition is given, number of cases where that condition is violated. If you do this, total possible cases minus the cases where the condition is violated, we get the number of cases that we want. Okay. So let's take a look at the question. 10 men and 2 women are sitting around a circular table for a round table conference. In how many ways can they be arranged so that the 2 women never sit together? So we are told that the women never sit together. If that condition was not given, what would be the number of cases? If the condition of the 2 women never sitting together was not given, there'll be 12 people around a circular table. So 12 minus 1 factorial. So the total number of possible cases in that case would be 11 factorial ways. But now that particular case is given that the women should not be sitting together. So from that I'll remove all the cases where the women are sitting together. So then I'll say that let the 2 women sit together. This is 1 unit of 2 women. And then there are the remaining 10 men that are arranged around it. So this 1 unit plus this 10 men will become 11 units. 11 units, in how many ways can I arrange them in a circular table? 11 units can be arranged in 10 factorial ways. But there is one more thing that you have to remember. These 2 women can be arranged among themselves. Suppose it is A and B. So A, B and then the 10 men would be different from B, A and the 10 men. So the 2 women also can be arranged among themselves. So this will be 10 factorial into 2. So the total number of cases where the 10 men and 2 women can sit around a circular table such that those 2 women are never next to each other would be 11 factorial minus 10 factorial into 2. So this would be how much? This is 11 into 10 factorial. So 11 minus 2 into 10 factorial. This is 9 into 10 factorial, which is option B. Okay. I hope you are able to okay, that's fine, Abhishek. If you are trying to focus on the exam, that is fine. For those who are already on social media and don't mind the distraction, I would say also follow our page because we will give you updates on time. Okay, I hope most of you are able to follow this. In general, this rule is super important to remember. Okay, if it is not easy, like direct application of formula is not possible, there is like extra condition is given. Say what is the total possible cases without that condition minus all the cases where that condition is violated. That gives you the total number of cases that we want. Okay, let's go to the next part, which is derangement. Derangement is unlikely to come, very small topic, but I'll still like to cover because I want to cover everything. So in derangement, basically the idea is that suppose there are say 4 people A, B, C, D, and they suppose there are 4 name tags A, B, C and D. The idea of derangement is that the person whose name tag it is does not get it. So the arrangement is perfectly wrong arrangement. That is, nobody gets their own name tag. So A does not get their name tag, suppose A gets B. B will get somebody else's name tag, suppose they get C's. C will get somebody else's name tag, suppose they get D's. And D will get their A's name tag. So over here you will see that the name tag and person are perfectly mismatched. Nobody gets their own name tag as such. That idea is basically derangement. The formula for this is that if you are deranging n items, derangement of n items, you put the apostrophe before n. This is equal to n factorial into 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial and so on till 1 by n factorial as such. The sign over here depends whether n is even or odd. If it is even, it will be positive. If it is odd, it will be negative. Okay, this is basically the formula for derangement. Very easy to do. I'll give you a slight additional part of it when there is partial derangement. So suppose you have A, B, C, D again. Now basically suppose that what is the how many ways can you derange the name tags such that A still gets his own name tag. So then you will say that okay, A gets his name tag but B, C, D are deranged. So in how many ways can you arrange A's name tag? There is only one correct arrangement. A gets his own name tag, but then these guys get derangement of 3. So this is basically what you should remember, that whenever such information is given, say that okay, in how many ways can people who are getting their ideal configuration get it? One way. How many ways can there be derangement? So that would be the remaining items derangement as such. Okay, this is the basic tenet that I have to remember. I would say that derangement, since the formula is slightly difficult to remember, just remember derangement of 2 can only be done in one way. That is, if there are 2 people and each one get the wrong thing, it can happen in only one way. Derangement of 3 can happen in 2 ways. That is basically you switch the order in a particular way that each one gets a different value. And derangement of 4 can be done in 9 ways. Derangement of 5 can be done in 44 ways. Generally, you won't get more than derangement of 5. If you remember these numbers, you will be able to answer questions on derangement very quickly. So here comes the question on derangement. I hope that all of you are able to solve it. Aviral, you're not very poor in PNC. Basically, PNC is firstly, it is a marginal topic. Many people ignore it, and because they ignore it, they become weak in PNC. Secondly, for some people, it is not intuitive. For a lot of people, like arithmetic is intuitive. Okay, this is going at this speed, that is coming at that speed. You can understand what is going on. PNC sometimes becomes slightly difficult for people to visualize and understand. So even if that is the case, what I would suggest is that remember the formulae, remember the methods, remember the guidelines. If you follow the guidelines, selection into arrangement, case by case method, even if you remember that, you will be able to solve PNC. If you are methodical, if you are deliberate, you will be able to solve PNC. Okay. So Miss Akor asked, ma'am, I'm thinking of also giving CAT. Should I wait for CAT exam to get over to start preparing for that, or should I incorporate with CAT prep? You can start preparing after CAT. If you're only focused on that, then you can start preparation before CAT as such. But there is like a significant overlap between CAT and ZAT. And what we do is basically after CAT is over, see basically suppose this is the portion for CAT, this is the portion for ZAT, okay? Okay, this is the overlap which is like 90% of both exams. The overlap is actually very fairly significant. So if you are actually preparing for CAT, 70 to 80% of ZAT is already done. There will be like some 20% or 30% left other than DM. DM is one section which is like completely different. But there will be like some parts of that which will not be covered by CAT preparation. Then after CAT is over, we just focus on this part entirely. So prepare for CAT with like full focus, full concentration. After that, in our ZAT course, we'll be focusing only on this part. Because we'll assume that you would have already done this. We'll revise it in our courses and our playlist, we'll revise it. But prepare for this well, so then you can ace this portion by fully focusing only on that after the CAT exam is over. So prepare for CAT exam. After the CAT exam is over, then we'll focus only on the ZAT specific part. Okay. I think this was an easy question. I this is an easy question. You should try to do that. I know that many people are not trying to solve at the moment, but try to solve, because it is very important to solve to really be able to understand and remember. Solving is the best habit. There are 6 friends A, B, C, D, E and F, each having their own bags. In how many ways can their bags be distributed such that exactly 4 friends do not get their bag and A is one of them? So A does not get this bag and 3 other people do not get their bag and 2 people get their correct bag as such. So 6 friends, so there are 5 friends B, C, D, E, F. So from these 5 friends, you have to select 2 friends such that they get their bag. Suppose E and F are these 2 friends who do get their bag. Okay, how many ways can you select the friends who do get their correct bag? You can do it in 5C2 ways. Now the selection process is done. The 4 friends who get incorrect bags and the 2 friends who get correct bags is selected. Now how can you arrange? Selection part is done, 5C2. Now how can you arrange? This part where each one gets their incorrect bag, this is derangement of 4, because none of these 4 will get their correct bag. This people who get their correct bag, there's only one possible arrangement where each one gets their own bag as such. So the total number of ways of getting doing this would be 5C2, which is the selection part, into derangement of 4 and into 1. So 5C2 would be how much? This is 5 into 4 by 2, so 10, into derangement of 4, which is 9, which is 90. So the correct option is what? It is option A. See, the beauty of many of these PNC questions is that many of the PNC questions, if you try to see, if you understand the concept, you can do it in 1 minute. There is hardly any question in CAT these days which takes less than 2.5 to 3 minutes to solve. If you're able to do a PNC question in 1 minute, you get that extra minute to give it to some other question. So always I say that do PNC questions. If they are on the easier side, you can do it very quickly. It will be done in under a minute and you can then solve more questions. Okay. Apart from general knowledge, all topics of that syllabus to be same as CAT. No, Ankit, there's a big difference. CAT Quant, ZAT Quant, very similar. CAT VRC, ZAT VRC, somewhat similar, 50%, 60%. CAT LRDI, ZAT DM, not at all similar, zero overlap. So that is basically what you should remember. Let's go to the next question. This is one formula. It can sometimes come, but I want you to be prepared for it, which is of sum of digits. Basically, if there is a number that can be formed with digits, say 1, 3, 4, 6, 8, okay, and we have to say all 5-digit numbers formed with this particular this as such. So there are 5-digit numbers, so these are 5 digits, so n in this case will be 5. So you'll say 5 minus 1 factorial. Sum of the digits, that is 1 plus 3 plus 4 plus 6 plus 8. So this is 18 plus 4, 22. Into this formula, it would be difficult to understand, but it is essentially 1, 1, 1 n times. So 1, 1, 1 in this case 5 times as such would be the total this. If you take this product, you get the sum of the digits. What is the sum of digits? Basically, if you consider all the n factorial ways of arranging these numbers, there will be n factorial numbers, right? 1, 4, 6, 8, 1, 3, 6, 4, 8. There will be n factorial such numbers. If you add up all of these numbers, what is the sum of all such possible combinations? This formula gives you the sum of all such possible combinations. Just remember, if there are n numbers, n minus 1 factorial into the sum of digits, take a sum of the digits, into 1, 1, 1 n times. You take this product, you get the sum of the all n factorial combinations of these numbers as such. So let me pose the question, try to solve it. Try to use the formula. There is a slight this condition that is given. So try to actually overcome that with a smart method. So you are given 4-digit numbers, but 0 is one of the digits. That is the only slight pain that is there. Very well done, Siddharth, Nipun and Aniket. Very, very well done. And I see that all of you guys have done exceptionally well. Vaishali, Sanjana, Saurav, VVC. You guys have solved most of the questions correctly, and that is extremely well done. Keep at it. This is very, very important that you keep working on your strengths also. Is number repeated 2 or 3 times? There the number is not repeated. It is always like each of these digits taken one at a time. There the number repetition is not allowed. We're slightly going over the time of this session, but I hope to cover everything so that it would be one and done. We don't have to worry about PNC again. Okay, so okay, let's see how people have done. Okay, I think mostly you understood the formula as such, but here there was a slight complication. See, if there was no complication, what would you have done? You would have directly used the formula. Here there are 4 digits, these are the 4 numbers, so you would say 4 minus 1 factorial, sum of digits 1 plus 5 plus 6 plus 0, this is 12, and 1, 1, 1, 1, 4 times. This would be the product. So this is how much? This is 3 into 12 into 1, 1, 1, 1. How much is this? 36 into, sum of the digits and 36 into 1, 1, 1, 1. Did I do this properly? So 3 factorial, that's what I was wondering. So this is 6 into 12, so that is 72 into 1, 1, 1, 1. This is 4 times. So 72 into this would be how much? So if I consider this, it would be 7770 2222. This would be 79992. This would be the answer as such. If there was no issue with the 0. But there's an issue with the 0. Why is there an issue with the 0? Because if 0 is the first digit, suppose if it is 0156, it is no longer a 5-digit number, which means that the value that we have found, 7992, has some wrong cases where 3-digit numbers are also considered. So from this 7992, I have to take out the sum of all 3-digit numbers such that 0 was at the start. So what would be all the sum of these 156 digits? So we have to consider sum of all 3-digit numbers such that they are made by 1, 5 and 6. So what would be the sum of such 3-digit numbers? That would be 3 minus 1 factorial into sum of them, that is 12, into 111. This would be how much? 2 into 12, 2 factorial into 12 into 111, which will be equal to 24 into 111. 24 into 111, I can write it as 2220 and 444. So that would be 2664. So this is 2664. So essentially from this 27992, I have to remove 2664. Ideally, first thing that you should always do is look at the options. If you look at the options, this is more, I can eliminate it. This is way lesser, I can eliminate that also. 7992, I have told you, is the wrong answer because I have to eliminate one case where 0 is the starting number. So only one option is really left. But even if you didn't know that, even if you didn't use that method, if you remove from 7992, if you remove 2664, you get 77328, which is option A. Always use options, especially in certain cases where you know that, okay, I don't know what to do in such case where 0 would be the first digit, but you get that none of the other options can be the answer. Therefore, one has to be the answer. Therefore, A is the right answer in such cases. Okay, we'll quickly go and do probability. This is the last topic I'll cover. Probability is something that comes directly from PNC. If you understand PNC properly, probability is easy to do. Basically, probability P is number of favorable cases of an event taking place. Suppose some event is there, that 3 will come in a die or heads will come in a particular coin. So that is number of favorable cases divided by the total number of cases in the sample space. So for example, if you throw a particular dice twice, so the number of cases in the sample space would be how much? The cases are 1, 1, 1, 2 and so on till 1, 6, and this is 6, 1 till 6, 6. So basically how many cases are there? When you throw a dice twice, you have 36 cases. So in that case, probability is divided by 36. Now what is the probability that both the values on both of the dice are equal? The possibility is that it is 1, 1 or 2, 2 or 3, 3 or 4, 4, 5, 5 or 6, 6. So how many favorable cases are there? 6 favorable cases out of 36. So the probability is 1 by 6. This is basically how you should think of probability. Number of favorable cases divided by total number of cases. Remember, the sum of all probabilities of the mutually exclusive collectively exhaustive sets, that is all the cases. If I consider case 1, case 2, case 3, all the cases that together give up the entire scenario, if I add them all together, I should get probability, combined probability as 1. So if probability of an event is E, P of E, then the probability that event will not take place is 1 minus P of E. P of A or B, this comes straight from set theory. You know that set theory, N of A or B is N of A plus N of B minus N of A and B, right? Now divide throughout by N of S and you get the same formula for probability. And the last one, which is independent events. Basically think of independent events where those two events have nothing to do with each other. For example, consider the case where you and your friend both are giving an exam. What is the probability both of you will pass? So the probability you passing has nothing to do with him passing. Both of these are independent events. So then you say that, okay, my probability of passing is 7 by 10, 70% chance of passing. My friend has a 50% chance of passing. So his is 5 by 10. So the probability that both of us will pass will be 7 by 10 into 5 by 10, that would be 35 by 100. So the probability both of us pass would be probability of A happening into probability of B happening. This is in case A and B are independent events. That is, the outcome of A does not influence the outcome of B. Okay, I'll give one quick question for this and then we'll end today's session. We have gone on way longer than we should, but we'll try to cover probability also. We have covered PNC properly. Probability also, I want you to understand how to do it so that you know exactly how to solve questions of this. I think nobody has scored a perfect score, but I think some of you have come very close to it. So very well done. Satkar, you are slightly late, but don't worry, we always put up all of these tests on our website. You can head over to cracku.in/live where you can see this in test format. You can take it as test. Okay, and you can then see all the questions, see all the solutions, you can submit all the questions, and you can see these recordings even later on. So we put in all the live sessions, we are recorded and put up on the site. So even if you miss the live sessions, you can always go back and see them. Okay. So you're scoring around 45 to 15 Cracku's mocks. How can I increase my score, especially in VARC? I would say focus on RC. 45 to 50 is slightly on the lower side. I want you to push it up to 60, 70 as such. So focus on RC. If you are especially below 20 in VARC, you have to focus almost entirely on RC. Give up on VA because VA is not the one which will get you a lot of marks. Focus entirely on RC, go all in, practice a lot of RC questions, get your RC score to be about 20-25. Then you can go to the VA part. RC is basically what you will get actually like guaranteed return. Very good, like if you put in a lot of effort, you will definitely get a return from RC. So focus a lot on RC as such. Okay, let's see how people have done. This is a slightly difficult question. I see many people are struggling over here. But that's okay. This is not an easy question. So let's see how, if some people are able to get this. Okay, I think only 2 people got it. I'm slightly disappointed, but this is not a difficult question. So a 9-digit number n is formed using the digits 0 to 9 at most once. The probability that n is divisible by 45 is what? So if a number is divisible by 45, what is it divisible by? It is divisible by 9 and divisible by 5. What is the divisibility test of 9? The sum of digits should be divisible by 9. And what is the divisibility test of 5? The last digit should be either 0 or 5. Now let us consider all the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. What is the sum of all of these 10 digits? The sum of these 10 digits is 45, which is divisible by 9. Now if you drop one of the digits, say x, once you drop this digit, the sum of the digits will be how much? 45 minus x. What is the possibility that 45 minus x will be divisible by 9? That would only be possible if x is divisible by 9. Only then would 45 minus x be divisible by 9, which means that x either has to be 0 or 9, which means that the digits either have to be 0 to 8 or 1 to 9. You have to either drop 0 or you have to either drop 9. Only then would the sum of the digits be 9, divisible by 9. So these are the two cases. This is case 1. This is case 2. So let us consider in case 1, suppose you have 0 to 8. You have selected the digits, 0 to 8 are there, no repetition. I have to find the, this, because it is at most ones, there is no repetition as such. How many ways can I arrange those numbers now? See, basically it has to be a 9-digit number, which means that 0 cannot be at the start. Again, the last digit either has to be 0 or 5. So this also I'll split it up into 2 cases. You have in this case 8 numbers and 0 is the last digit, or you have 8 numbers and 5 is the last digit. So if 0 is the last digit, the remaining 8 numbers are 1 to 8. In how many ways can they be arranged? They can be arranged in 8 factorial ways. Now if 5 is over there, in how many ways can you arrange? Now you'll have 0, 1, 2, 3, 4, 6, 7, 8. So 0 to 8 minus 5 is there. In how many ways can you arrange those numbers over here? See, 0 cannot be in the first plot. So in the first spot, you can only put 7 numbers. The remaining numbers can be arranged in 7 factorial ways. 0 cannot be put in the first spot as such. So that one case you have to remove. The first slot can only be filled in 7 ways and the remaining values can be filled in 7 factorial ways. So the total number of cases for this particular case where 0 to 8 is taken is 8 factorial and 7 into 7 factorial. These are the favorable cases as such. Now suppose 1 to 9 is taken. 1 to 9 is taken, 0 is not there, so the last digit has to be 5 for it to be divisible by 45, which means that you will have 8 numbers followed by 5. These 8 numbers can be arranged in 8 factorial ways. So what is the number of favorable configuration? N of E. This is the sum of 8 factorial plus 7 into 7 factorial plus 8 factorial. This sum is equal to 2 times 8 factorial plus 7 into 7 factorial. This is what we get over here. This is N of E. Okay, I'll put N of E over here. So let me clear that up. N of E I found as 2 times 8 factorial plus 7 into 7 factorial. Now I have to find the sample space. How many 9-digit numbers can even be made using this? Forget divisible by 45. How many 9-digit numbers can be made using this? So how many 9-digit numbers can be made? See, you have 9 digits over here, 4, 5, 6, 7, 8, 9. The first digit cannot be 0. That is the only restriction, which means that the first digit can be filled in 9 ways. The remaining digits can be filled in 8 factor. You have essentially 9 possibilities over here, 8 possibilities over here, 10 possibilities over here, 6 possibilities, 5 possibilities, 4 possibilities, 3 possibilities, 2 possibilities. So essentially you are getting a 9 factorial number of ways over here. So essentially how many 9-digit numbers can be made using 0 to 9 at most once? That is basically 9 into 9 factorial. That would be the total number of possibilities. So n of s is how much? 9 into 9 factorial. So let me find n of e and divided by 9 into 9 factorial. So probability of this number n being divisible by 45, p of e is this 2 into 8 factorial plus 7 into 7 factorial divided by 9 into 9 factorial. I divide throughout by 7 factorial, so I get 2 into 8 plus 7 divided by 9 into 9 into 8 as such. So this is how much? This is 16 plus 7, this is 23 divided by 9 into 9, that is 81 into 8 is 648, which is option D. So as you can see, slightly difficult, slightly complicated, required you calculating firstly the number of favorable cases, total number of possibilities, dividing A by B, you get the answer. But the core of probability has always been P and C. If you get P and C properly, you get probability properly. So this is basically the revision session on PNC and probability. I know this was like difficult, many difficult questions were there. Initially it was easy, but if you go into all of the different possibilities, it becomes slightly complicated. If you are somebody who doesn't do well in PNC in general, what I would suggest is at least revise on the basic concepts. If a basic simple question comes, you should be able to solve it. If it gets complicated, maybe you will not be able to solve it, but the easier questions you should definitely solve. Because as you saw in some of the easy questions that I put over here, if you understand the concept, you can actually solve it in under a minute, and that is very, very valuable. So always be at least comfortable in PNC, at least in the easier part as such. Okay, so this is a good bye from me, and thank you guys for joining. And I know that many of you put in a lot of hard work to actually solve these questions. Excellent work, Aniket, Siddharth, VVC, Nipun, Vaishali, Sanjana, Saurav, Prats, Aditya. Excellent work from all of you. I want to see you keep doing well, keep striving, make sure that you do well in actual CAT. Thank you guys, thank you all those who have joined us, and remember, take a bookmark the revision videos playlist. In the last few days, I want you to see them. I want you to cover the entire syllabus again. Make sure that you see all the formulas. I forget formulas, I forget cosine rule formula, I forget many formulas that are there. So make sure you see those revision videos. I don't want you to forget any particular concept. And I also want you to see the top 100 quant questions. So thank you guys for joining me.